Good morning, everybody. Can you guys hear me in the back okay? All right. Well, welcome to BSides, everybody. Privileged to be here. My name is John Laycock. My partner here, Chris Rogers. We're here today to... Louder. Okay. Sorry. My name is John Laycock. My partner Chris Rogers here. We're here today to talk to you about deductive reasoning and file analysis technique. We're going to start with a product demo. So please go ahead and lock the doors, guys. Get comfortable for the next 2 hours. We're going to take you through in great detail graphs on the current ADT landscape,
Diagrams are the best deployment practices for your environment.
kill chain optimization of your current infrastructure for synergy.
And most important, pricing and availability.
Just kidding. I know nobody wants to sit for 2 hours in that. So again, my name is John Laycock. I've been involved in forensics for a number of years now. You can see a number of my various stops there. Currently, I work for Fidelis Cybersecurity on our threat research team. I work on the systems team. And Chris also has a varied background as well.
Yeah, mostly government contract stuff. I did work for Bank of America before coming to Fidelis. Senior analyst, research, malware stuff.
Use the mic.
Said yes, I work malware. All right.
Okay, sorry. Forgive us on this. We're trying to work with the one microphone. So.
You can actually pick up and hold the mic, it's okay.
Okay, pass it back and forth. All right, so this actually started, I'm a Sherlock Holmes fan, and Sir Arthur Conan Doyle, through Sherlock Holmes, wrote in The Sign of Four about deductive reasoning. And so he said that, if you see 1,000, crime scenes and pieces of evidence, and you know what's going on, the 1,001st shouldn't be a surprise. We could actually apply the exact same logic to malware analysis, and if you've seen thousands of malicious files and know the behavior, know the symptoms, you can relatively easily pick it up and find the malware without actually going into any heavy dynamics or anything.
So just a little bit of a disclaimer here for this talk. I know we're going to have a lot of people from various skill levels and backgrounds. This is really intended to be an introductory type level of talk. All right. A lot of the things that we're going to show you wouldn't be necessarily considered forensically sound, but these are things that if you have a man on the computer has something on there and you want to take a look at it, you can.
He is speaking up.
Sorry, I don't get the feedback very well. I've got bad ear. So basically, if we've got a system on a file on a computer that looks a little bit suspicious, we're going to give you some tools and capabilities of how to take a look at it and kind of critically analyze it and determine whether or not it's actually malicious. And so this is just basically, we know this is a very deep topic, and we know that a lot of these techniques are going to be basic for some of you. So please keep that in mind as we go along.
Yeah, if you're not in IR, then you're probably doing it for your family. So what is malware? It's really just a variety of evil logic, What isn't it? It's not magic. It's simply, a series of instructions, because computers at the basic level are just tools. They just translate binary instructions into cat pictures or, Left 4 Dead. And, bad guys, shady marketers, because of the user-friendly nature, they take full advantage of it and get their little collection of bits out of your system. So talk about vectors. Email, web, you've seen them in the news, you've seen them everywhere. It's common. It's something that everyone knows, this is how stuff gets in. It gets in through the wire, it comes in through the internet. So how is this still a thing? I mean, it's been 20 plus years, and the same methodology is still being used. Well, a lot of it has to do with user-friendly-itis. The user experience is paramount, especially in a corporate setting. You have to, go to the user, and give them whatever they want. There's a lot of legacy stuff, backwards compatibility, and really, it's kind of crippling. So, I mean, we're in 64-bit architecture and we're still getting 32-bit malware fully deploying on the systems.
Yeah, everybody has this experience. I'm sure, you know, you go to a network and there's a server there running NT4. You know, that's what I call the don't F with it server. You know, every server has, you know, basically it's running some legacy application. It works. You know, just don't mess with it, leave it in place. But that oftentimes is one of the biggest vulnerabilities that you have in your network. It's old, it's unpatched. You know, just don't F with it, leave it alone. So those are all things that work against us when we're looking at a network in a security posture.
Yeah, the end result is always the same. Attacker gets in, system gets owned, and they get whatever they want, whether it's information or money or just control. So we're going to tell you right now, we're going to break down a little bit of the file system stuff you could do in an incident response.
Okay, I'm going to kind of take you through a little bit of what you might see in the beginning, you know, your so-called incident response type of situation. But basically, if it looks like malware, smells like malware, it's probably malware on your system. Okay, it probably wasn't that fuzzy cat screensaver that you thought you were downloading. So one of the first things that I'm going to talk about are map times. For those of you not familiar with map times, MAC stands for Modified Access Control. And those are the timestamps that are on your different files. And this is one of the things that malware authors will try to play with from time to time. And you'll see lots of different ways. But basically, I'm going to give you a couple of things you can take a look at to look at your particular file that you might have on your computer. So Windows is one of the more prevalent operating systems. You know, you're going to encounter NTFS. That's probably one of the more common file systems that's out there. And the way they list their file structure is using the master file table. And if you have never looked into the master file table, it's a deep, deep topic. And essentially what we're looking for in here, there's two sets of timestamps. There's the standard information, and then there's the file name timestamp that's embedded within the master file table. Now, when we talk about those two different sets of timestamps, the one that you interact with as a user is the standard information timestamp. So when you pull up the file properties, like you see here, you're looking at the SI time. And in this case here, we've got the created and modified. It was November 2005. We can see that the file was accessed in November of 2014. Now, for this file, this IR evil DLL, this is what it looks like on the surface. So you as a user, this is what you see. Now, if we want to kind of dig a little bit deeper, if we want to look a little bit deeper, thank you. So if we want to get in a little bit further detail and figure out what's going on, we can actually use some tools that are commonly available. As I go through some of the slides and as Chris goes through, we have a number of links at the back of the slide deck, and we'll have this up on SlideShare later on. Number of links are just some things you can reference, files or programs you can download to help you out. First such tool I want to talk about is FTK Imager. We use this a lot in incident response. It's just a nice handy tool to have in your tool belt. In this case, though, we're just going to use it for a very basic usage. We're just going to grab the master file table and take a look at it. You can actually go through and image your whole system. You can create a forensic image using this tool. I've done that lots of times. In this case, like I said, we're just going to export out the MFT and take a little bit of a closer look. Sorry. And once we've actually exported that out, there's a really nice command line tool that I've used in the past called MFT dump. And what this does is it takes the contents of your master file table and dumps it out to the CSV so we can take a closer look. And in this case, you know, I spoke about the standard information of the file name times before. We can see that they don't match up. You know, Excel is great for just kind of doing a really quick look at this. And we can see because these times don't match up, we can actually set up a filter to show us where the SI or the FN file times don't match. And that should raise a red flag that this file has been tampered with. We might want to take a closer look at this. And some of the things that Chris is going to talk about will help you kind of do some more further analysis with that. One of the other places we can look are on the actual file system itself. Just open up Windows Explorer and start poking around. You know, it used to be pretty simple. Most of your malware authors, they're lazy. So they would put the same files in the same location, and it was pretty easy to go through and find these different files. Yeah, it works. All right. As the complexity has increased, there are a lot more locations. We have different operating systems, different versions of Windows that are coming into play. And so there could be potentially dozens of different directories to look for. And I have, again, some links at the end of the slide deck here in the reference section that you can go through and look at to you know, get some ideas of some places to look for suspicious files. But essentially what we're going to be looking for are things that just don't belong. You know, one of these things is not like the other. All right. In this case here, we're looking at Windows System 32. We see the IR-evil DLL and the IR-evil.exe files. These stick out like a sore thumb. You're not always going to be that lucky, but you know, in certain cases, it will jump out at you. Sometimes you'll see Chinese characters or Cyrillic characters. Basically, just anything that just doesn't look like it fits within that direction. Okay, and here's again just a list I put together for you guys with these slides. Just some common locations. Again, this is just one of dozens of different places that you can look. But these are some pretty common ones we see when we've done some of our casework. Now, another thing that we'll look through when we're trying to figure out if we potentially got some sort of suspicious activity on our computer is the registry. Okay, and we can use regedit. I'm sure a lot of you guys, if you're from an IT background, you've gone through and used regedit to do a lot of different things. In this case, what we're looking for, the bad guys, they want their malware to keep running. So if you reboot the computer, there's no persistence necessarily set up. And persistence is what we call when malware has basically been entrenched on the system and we reboot it. And, okay. So basically, we're looking for just evidence that this malware is going to persist every time we reboot the system. And again, just like we have with the file system location, we're going to have a number of locations we can actually look through. And in this case here, this is an example of the IR-evil.exe file we have on the system. You can see it's under HP, local machine, software, Microsoft, Windows, current version, and then the run key. There's actually an entry in there. So there's actually some legitimate files that you'll see in here. You'll see the Adobe Reader, the programs that we all use and we want to start up as we use our computer on a day-to-day basis. However, we don't want that IR-evil file. That's there. And so what we, one of the things we can do just to do a little bit more information, maybe about perhaps when that key was put in there, we can save out the actual registry key. And so again, just using regedit, this is tools already on your system. You just go File, Export, you save it out as a text file, and you can see as I'm doing here. And this saves out the actual text. If you open it up, you get some real nice information. You can see the last time that key was written to. And we see that November 2nd, 2014 date again. Okay. One of the things we do as investigators is we try to look through all these files and try to establish a timeline. That's why the time stopping thing is so important, because if they're throwing, things into play to kind of throw us off track, basically. So, again, just a list of some common registry keys. Escape key is not one of them, obviously, but these are some common locations that you'll see. Again, some links at the back of the slide deck to show, any one of dozens of different keys that you can use. The other thing that you can do too, if you want to get a little bit beyond regedit, Microsoft has sysinternals, which have a number of nice tools that are really good for incident response. Autorun is a great tool. It will give you more than just the registry itself. It will give you some things we'll talk about here in a minute with Task Scheduler and some other applications where they'll actually do some startup entrenchment through your files. Prefetch is another place that we can take a look. I'm not going to get too deep into this particular topic, but basically, starting with Windows XP. Okay. Starting with Windows XP, prefetch files were created, and basically just to help you speed up the startup of a lot of the applications that you use on a day-to-day basis, help them boot up and start up faster. And so this directory actually gives us a really good indication of files that have been run on the system. So in this case here, we've got the Windows prefetch directory, and if we look in there, the create time of that file itself will give you an indication when that file might have first been run on the system. And there's actually parsers online that you can download that'll give you some of the extra information like date and time that it was first run, last time of execution, every time it's run. That's all embedded within the prefetch file itself. And one last thing I'll talk about here is the task scheduler. And this is basically another method for persistence. And you can see we've got this schedlgd.txt file that, depending what version of Windows you're running, can be located in a couple of different places, either under the Windows directory or Windows tasks. And it's just a nice log file, basically, that gives us some information about a particular task or job that's been scheduled on the system. In this case here, we can see that this IR Eagle job was started on November 2nd. Again, we're seeing that date again, November 2nd, 2014. And in this case here, this file didn't run properly. And that could be for a lot of different reasons. It just could be maybe they don't have .NET framework on the computer, or just they're missing some random dependency that they need. But this gives us an indication that they're trying to start this file up. In this case, they may not have been successful. Now, as I said, that schedule log text file is a log file essentially. There's actually .job files that get created when we set up a task. And so we see in this case here, we've got IR-eagle.job. We can actually open that up in the task scheduler and take a closer look and see some more information about that particular job. So, just a couple of different things to look for when you're initially just trying to kind of triage your file and think, maybe we need to take a closer look at this. And I'm going to turn it over to Chris, and he can kind of walk you through just some of the things, some of the tools that are out there and things that you can do to take a closer look at some of these files that you might have discovered with some of these methods.
All right. So, you're actually actively going up to Nana's system. She's got something on her computer. You've gone through the locations, and you're not sure about files. So what do you do? Well, as a detective, or you're going to collect clues, you need a toolkit. You need some way to get the information so you can process it and then make a determination. So the first thing you want to have in your toolkit is the internet. It is definitely we live in the information age, and for every cute cat picture or funny video, there's 2 or 3 malware bloggers talking about something on the internet. So you can just go out there, Google it, hopefully from a clean machine. I think you had a story.
Yeah. One example I had is my uncle actually, true story, my uncle had a piece of malware on his system. This was probably 10, 12 years ago now. And it was just some stupid little gag thing he got in an email. And so he's like, I'm like, yeah, I think you got a virus here. Hold on. So I took a closer look. I'm like, well, you have a virus in it? No. All right, well, let's just grab Norton or McAfee. And every time I would try to go to Norton.com or McAfee.com, boom, you shut it down. So, right in the browser. So they are trying to cover their tracks with this stuff. So, just be aware you want to use a clean system when you're doing your research and things like that.
Yeah, and we all have phones and make it the internet, so that's a nice and easy way to do this. The second thing you're going to need is a hex editor. So, high-level view of the hex editor, it takes the binary little bits and puts them into ASCII hex, and that ASCII hex that you see here actually translates into a little human-readable text over here. And all of this is searchable as a file header. You can take the first few bytes there, plug it into Google, and you should come back. I think Gary Kessler has the largest batch of file signatures today. So as you see here, we have a funny cat JPEG, but the first two, 45A, is actually an executable file. So it's not what it says it is. And so when the computer reads it, it's going to read it based on this information and not the extension. The next thing you're going to need is an entropy analyzer. I don't know how many of you know Entropy, so just bear with me. What you're looking at here is 2 files. This one's uncompressed, and this one's using a compression of some sort. And entropy is the measurement of order or disorder in a file. Land information. It's actually, what is it, the natural order as well.
Yeah, scientific, it's natural disorder.
So what we're looking at here is the same file, compressed and decompressed. The first one, you can tell there's a bunch of patterns and data clusters that you can actually key in on, and the entropy is fairly low. And this file over here is pretty much scattered, it's very random, and a high entropy. It's used to like hide stuff and compress files. You want to keep people from seeing what's inside. Oh, and this is the Shannon formula that Claude Shannon came up with in 1948, I think. For those of you trivia buffs. So the next item we want is a hashing tool. You can use hashtag. There's a dozen of them. If you're familiar with Python, there's PE file, and a variety of different things. So, but why hashes? Well, hashes are essentially fingerprints of a file. This is the way that the file, instead of typing in, service host.exe and coming up with 1,000 different things, you type in the MD5 and you're going to get a whole different thing, because this is actually what the file is. And as we break down the hashes from CRC32 down to the SHAs, you can see that the number of characters increases. MD5 and SHA-1 are pretty much industry standard. You're going to hear about hash collisions. A lot of math geeks get together and they try to basically break the algorithms. It doesn't invalidate them. I've yet to see an MD5 collision in the wild, and I've been doing this for a while. SHA-1, and that's even more. It's 40 characters as opposed to the 32, so it's even more accurate. And there's a variety of SHAs. 256 is starting to pick up a little bit, but there's also, I think, the 256 and 64. 512, yeah, which has 128 characters, is the largest SHA. The SSD you see here, that is fuzzy hashing. I don't know if you guys heard of fuzzy hashing. It's a wonderful way to compare two files. You have the block count and then two different hashes, and those will you'll be able to tie those to other files and create family resemblances. It's good amongst it's really good on text files. Some of the compression algorithms will screw all that up, and so you might not get a relation. The authentic hash you see there, Windows active code. You guys have seen that. Right click on a file. That's what that is. It's just another hash that they use to authenticate the integrity of the executable file. And the imphash. The imphash has been gaining popularity. When a compiler works and compiles an executable file, it takes all of the imports and loads them in a certain order. The imphash goes through and says, okay, well, here's the order, and it hashes, that series. And then you can compare that with other stuff. What that tells you is that it's the same compiler. So it's not going to tell you it's the same malware family, but the same compiler. So you can actually equate it to actors or sets of actors. You'll see in if you go out there and look at the news, you'll see, after the sharing stats, there's a variety of stuff going on out there. Now that I've bored you with that, an analyzer or a peak information tool. There are a dozen or more out there. They apply signatures to stuff. This one's probably one of my favorites, PE Studio. It's a beautiful thing. It actually has so many signatures that are automatic. So you just drop the file in, and it will go through and it'll look at all the signatures that it knows about, and it'll tell you, hey, I think this is suspicious because X, Y, or Z. And you can use, you can use your custom, you can use Yara, for those of you that know Yara, and PE Explorer. There's a dozen of them. And what they do is they'll break down the file with the information. Again, you see the hashes. And there's a variety of different things they do. It's available at winfor.com. Mark Oshmeyer? Yeah. He's a great guy. The P information. Why is this important? Because all executables have a header, and the header is not human readable. I don't know how long you can do it before you can do that, but it pulls out stuff like the creation time and compilation time, which, like John was talking about with the time stomping, it's It's kind of easy to mudge this, but most malware authors don't. If you set your system time to something old, you can compile it and it'll be old. And most of the compilers, when they run it through and they run thousands of files through in order to get the malware out there, it'll have a more current time. So now you have the tool set. What do you do with it? Well, you go out to the file system, and the first thing you want to look at is you want to look at the file names. And like John was saying, if you see Cyrillic or Russian characters on Nana system, there's something wrong. That's a big clue right there. Service host that's misspelled. If you got some misspellings or something that's close to Windows but not quite, that's another clue. And then there's the total random character. I created this, with a piece of code. The only thing simpler than finding something like this is finding, pdf.exe or word.exe. The hash. We just talked about the hashes. So what do? You go out to Google, go out to VirusCode, go out to Total Hash, see what's out there. They'll give you options to upload the file. Just know that if you're uploading a file, you're losing control of the file. You no longer have, whatever's inside the file. So if it's a key log, that was dropped by the malware, now Nana's recipe and all the bank account information's on the internet, which is never good. File type. We're talking about the Hex Editor. This is where the Hex Editor is really awesome. So here you see three different file types. Sorry about that. And this is the old Office D0CF11E0. Here is the new Office, which is XML in a compressed file, or PK. And then down here you have the executable or MC header. This is really where you're going to, as a human looking at the binary with a hex editor, you can actually pick out some of this stuff. And you can dig down through and pull up strings and stuff if there's nothing blocking you or compressing the file. The size. How does size play a part in anything? Well, it's pretty relevant. If you got a PDF and it's incredibly small, or if you got Word docs or PowerPoints and they're really large and there's only like one page or 2 slides in them, that's a key indicator that there's something that might be up here. And so you want to take a closer look. How do you do that? Well, you break the files down. Now, this is actually pretty cool because those Office files and with PK header, it's just straight compression. So you could actually take 7-zip, which is what I did in this case, and in this one I took an executable file and I just said, hey, go ahead and extract this executable file. And this is what you come up with. You got the text section, the R data, the data, and this resource section. But what you're going to find more often than not is in that resource section that the malware authors are going to stuff other things. Like they'll say it's an icon file, but it's another executable. So you can just dig through that, repeat, lather, rinse, repeat, go through the process, and then come up with a better determination on the validity. This is what a PowerPoint looks like when you break it down using the zip format again. It breaks down into all these wonderful little XML directories, and you see here, these are the slides in XML format. And look, there's a exe right there in the slide, so there's probably a reference in there. It's never going to be that easy, but you can go through and find something that's suspicious, or do this with an Office document and look for the VBA code. It'll break up. Which one? Oh yeah. There is a CVE 2015-4114 that we just wrote a report on, and that was exact same thing. They basically packaged up a new vulnerability. It was an INI vulnerability, I think, in PowerPoint, and they just packaged it up. And, using the slide. So there's a big file, one slide, relatively easy to find once you extracted it. Hey, look, this doesn't look right. Time. Now, John talked about time stomping. How is time important to us? Well, here you see, this time is 2008, which 8 years old. So if you go out and you look up, wget, and you look for this specific package, you should be able to find some information online, something to compare it to, or just download another version, so and check the versioning, check the rest of the data. If it's too old or too new, then, and doc round's not involved, you need to question the file. The metadata. Metadata is literally just information. So you go ahead and you look at it. What was this created by? Was it created by a tool that should have been created by? Who was the author? How many pages? There's a lot of information you can do to say, hey, this looks suspicious. And with everything else, you can make a determination that this is a bad file or this is a good file. Yeah, QPDF. QPDF's a big one that the attackers like to use because it's very malleable. Entropy. We talked about it a little bit earlier. I'm going to break it down for you, so try to stay awake. Here I use CryptTool, free tool that is just phenomenal. And I downloaded the sign-up form from Project Gutenberg, and I went through and I just did an entropy check on it. And there you see the entropy, it was pretty low. Then I went ahead and used the same tool. I did an encryption, a symmetric encryption using RC4 with the key F00D. I pushed encrypt, and this is what it looks like. So you have the plain text over here, and this is the encrypted version on this side. As you can tell, you can easily read this, and if you can do this in your head, then we have a job for you. And you see the entropy is way high. The reason you want to look for high entropy is malware authors will change and they'll repack something just using a cryptor or using a different style, and this is a way to get it past AB. But as a human, you could easily go and just do an entropy check on it and say, hey, this doesn't look right. And let's see. Oh, sandboxes. So a lot of times sandboxes aren't right. They're phenomenal tools. But there's times when they don't work. And if they don't work, and you look at the static detections, you can tell it's malware without doing any sandboxing. I mean, nowadays there's virtual detection. There's
So some examples you'll see in some of the malware samples that are out there are, they'll be doing registry checks, looking for existence of VMware, VirtualBox, looking for existence of Wireshark and things like that. And if the malware detects that, it'll actually change its behavior and just shut down or deliver a different payload or something along those lines. So, it's kind of a cat and mouse game. We keep going back and forth. We adapt, get to new tools to try to detect what the malware guys are doing. They adapt to what we're doing. We go back and forth and back and forth.
Yeah, even Kevin Green wrote a lot of good RAD decoders, and now we're actually seeing malware authors, use that and put, lovely messages in there about those decoders in some of the breakdowns. Debugger checking, time checks, there's ways to basically kind of hinder analysis for those of you doing a little more advanced analysis. And sometimes there's just weird dependencies. Either you get a file, but you don't have the accompanying file that was on the system, or the file, like John was saying earlier, needs, like Stuxnet looked for a specific keyboard type and would install and work only if that was present. And sometimes you're missing a component on the host system. So you're trying to do something, you got the wrong version of Word in your virtual environment or Sandbox. You got a variety of different things that could prevent it from detonating properly. And then the malware itself could use other techniques, like it could go out to a known site and try to pull back the IP address, and if it doesn't jive, then again it picks a different fork. Going back to laterals, to using the internet and trying to gather information. If you go out, you have a file, you send the hash to virus total comes back 056, AB vendors detecting it, doesn't make it a good file, it just means that no one knows about it. And so laterals are great, but you gotta vet them a little bit. You gotta use a little of your resource and try to make a decision whether or not that is valuable. Sometimes malware Malware reports will be very high level and won't give you the technical details you need. So, just kind of pivot off there and go find something that, will help you make a determination. The whole thing that we were talking about can be related in a couple stories that we had from, experience. There was one time we had a response and we went out to the file, went out to the system, we had an alert. We get down there, it was a common location, the file was just, they had a scrambled name, high entropy, it was obvious. So we were able to pull the file out. We threw it in our sandbox, and it didn't work. And so then, when that happens, then you have to take it to the next level, try to figure out what happened. So we put it into the malware analyst's hands, and we saw some weird system checks going on. And we're like, well, system name checks. And we're like, well, why is it checking the system name? And it checked the system name, and it would just kind of sit there and spin for a while, and then terminate. And so we didn't know what was going on, following the code down through the path. Well, come to find out, when it installed itself onto the original system, it queried the original system's name, added it during the melt, or the melting process, and then was looking for the system and comparing it to the system name that it was currently on. And if it didn't match, it completely went a different way. So once we were able to go ahead and bypass that, we were able to get all the beaconing information, figure out exactly what it was, based on behavior.
Okay, so another scenario we had, we had some network logs. We saw some really suspicious beaconing going out to some Chinese addresses I don't remember.
Random times.
Yeah, it would go like once a week, twice a week, just very randomly. And so we pulled it down and started looking at it, and just we were really fighting it. And so basically after a lot of gnashing of teeth, we realized that there were some very critical dependencies we needed to have with this particular piece of malware. We had to have a web browser open, and had to have a paint file loaded up in the browser itself to actually execute the payload for the malware. So, just keep in mind, you may have a very suspicious file out there, but, you can't get it to run. And you're going to have to start getting creative, look at system calls it's making, try and figure out what it's doing before it actually executes the payload. So, Chris?
Yeah, but like we're saying, the techniques that we showed you guys, they're not new, but you can use them, determine that it's malware without actually knowing what the malware is. Going beyond Windows, these same tactics could be applied. What we're looking at here is an elf header for all you Xers out there. And I mean, literally, you can search stuff, you can use a lot of the same tactics, including trying to decompress an ELF using WinZip. It'll break it down into the components, and it's just a really nice way to cheat. So in conclusion, I know you're all breathing a sigh of relief. What we want to let you guys know is some clues are key indicators. It's you can get the smoking gun just looking at some of the stuff. Dark Comet has a specific mutex. I think, where's Harold? Harold wrote a wonderful Dark Comet thing for our blog. And some clues, you can get a massing of clues, but you won't have enough to make a final determination. So even though you have like a weird file name in a known location, sometimes the glove doesn't fit, so you got to move on, try different things. And I think the final fitting quote that I'm going to leave you guys with ties this whole thing back together, that the more bizarre thing, the less mysterious it proves to be, which, if you go out and you see and it fits all the criteria, it's bad. But if you got something that, looks like a system file, but it's behaving erratically, those are the ones that are really, really hard to define. You good? Yeah, I think that's it. You guys have any questions? I think we have 5 minutes.
Oh, okay.
Huh? No? We don't have, no questions? All 5 minutes? All right.
I've got a question right there.
Okay, yes.
So how do you deal with ASLR?
How do we deal with ASLR? that is a good question. If you have access to the host and you can do it natively, that's probably your best bet.
I don't know of any good, good automation for that.
We spent a lot of time on the network side of things.
Yeah, we do a lot of network detection, a lot of network type stuff. When you're looking actually at the physical system, it's a bit more of a sticky wicket. Anyone else? No one's got tomatoes, no one's got anything? I think we're done then. Thanks.